Now, if you didn't watch the previous video, or if you did listen, or watch it but didn't listen, I'm going to tell you, if you're not refreshed and you're not like, oh wow, I'm really excited about studying math right now, you're going to completely check out, and I can't spell because I'm too busy giving you a lecture. Multiplication, because we're going to be doing matrix multiplication, and to be perfectly honest, it's not all that straightforward. It's not that bad, but if you're tired, you're going to have a hard time getting through this. So again, if you're in any way like, man, I could really use a soda right now, go get a soda. Then come back and be fresh and ready to try this out. All right. Matrix multiplication is very specific. You can't multiply any two matrices together in general. I don't want to say that. Maybe what I want to say is you have to be careful. When multiplying matrices. First of all, the first step is to check the size, because it's not just like they have to be the same size. In fact, most of the time they're not the same size. So what you need to do is say I'm going to multiply A times B. A times B. What I want to do is I want to check the number of rows and columns. So say A is an M by N matrix, so it's M rows, N columns. And B is an N by, say, P. If these numbers are the same, I can do multiplication. And if I do the multiplication, the answer is an M by P matrix. And by that, I mean it's an M by P. So this is really weird. So you're probably already like, man, I should have gotten that Coke. The numbers inside the columns of A has to equal the rows of B. And I can never remember it when I say it, so I just have to remember, if I write the sizes next to each other, the numbers on the inside have to be the same. The size is the numbers on the outside. Okay? So if I've got something like, let's just do a couple of, I think what the important thing is to say before I go on is, if they're not the same, I can't do it. I can't do the multiplication. Just be more specific. I can't. Come on. Okay. So this is pretty standard, just to do some examples like this. If I have a matrix that's a, I'm not even going to tell you what they are. I'm just going to say, if I have a 3 by 2 and a 2 by 6, can I multiply these? Can I multiply these matrices? The answer is yes. These numbers are the same. And so what's the size of my answer? The size of my answer is going to be a 3 by 6 matrix. So yes, I can multiply. My answer is going to be a 3 by 6 matrix. Okay, so what if I have a 2 by 3 and a 3 by 4? Can I multiply these? Yes, I can multiply these because the 3 and the 3 are the same. Now what's the size of my answer? The size of my answer is a 2 by 4, because those are the exterior dimensions. Just make sure you got this, because this is absolutely critical. You hate to start multiplying matrices and find out that halfway through that you actually can't even do it after you've already started trying. So what about this one? Can I multiply? Oh, absolutely. You bet I can. The numbers on the inside are the same. So yes, I can multiply. And the size of the answer? The size of my answer is going to be a 2 by 2. That's a terrible E. So I've got an A, B that are a 2 by 3 and a 2 by 3. Can I multiply these together? Multiply these together. No. And a lot of people say, well, they're both 2 by 3, so can I multiply them together? No. The 2 on the inside have to be the same size. If they're not on the same size on the inside, the answer is no, so there's no answer. So I can't even find the size of the answer because there isn't one. All right? Got it? Got it? Kind of? All right. Well, I'll show you how this is applied, and we'll actually go ahead then and start actually doing the matrix multiplication here. So basically what you're going to do is I'm going to write this as an example, but we're going to be pretty slow and methodical going through this. So say I've got 2, 3, 6, -2, 5, -1. And I want to multiply it times 6, 2, 1, 0, 5, -2. Oops, I made that the wrong size. So oops, slow it down. There. Okay. So I want to multiply these out. So first of all, I want to check and make sure I can do it. So this first matrix is a 2 by 3. The second matrix is a 3 by 2. These are the same. So my answer will be a 2 by 2. Good? All right. Can you tell I'm really excited about doing this? So what I'm actually going to do, I think, is I'm going to take this, I'm going to copy it. I'm going to cheat because I can. I'm going to paste it here, and then I'm going to paste it here. I'm going to make 4 copies of it. I'm going to paste it here, and I'm going to paste it here. And I'm probably going to have to move them, but I at least wanted to have 4 copies. Alright, so I've got my fancy little matrix here. Alright, so the first thing I'm going to do is so since I have a 2 by 2 for my answer, 2 times 2 is 4, so I'm going to have to do 4 operations, or 4, I'm going to say 4 steps. It's going to take me 4 steps to get this answer. Alright, so the first step that I'm going to do is I'm going to take the first row in the second column. I'm going to multiply every element in the first row by the first column of the second, like this. So I said my answer is going to be a 2 by 2, so I'm going to have 4 blanks, a blank, and a blank, and a blank, and a blank. We're going to work on solving for what's in this blank first. Okay, so that's the one that we're getting. So what I'm going to do is I'm going to say, well, this blank here is going to be 2 times 6 plus 3 times 1 plus 6 times 5. Okay, so that's 12 plus 3 plus 30, 15 plus 30, or 45. So that answer there is 45. Okay, and yes, this is what matrix multiplication is like. Yay, it's super ridiculously awesome. Okay, so let's work on the next one. So I've got this one. Now I've got 3 more blanks. All right. let's say now I want to work on the first row of this one and the second column of this one. In fact, I'm going to color it a little different. The second column of that one. But that's green now. Now that looks funny. Oh, purple. Okay. So now this one is the first row, second column. First row, second column. So that's going to be this answer. Like that. Good. This answer comes from multiplying 2 times 2 plus 3 times 0 plus 6 times negative 2. Just like that. So that's 4 plus 0 minus 12, which is negative 8. So that answer in there is negative 8. Now, I can already tell that multiplying matrices is going to be your favorite thing to do on a calculator. So I'm going to force you to watch this. Or I can't force you to watch anything. You can always turn it off. But I do want you to see where this comes from, because one day you might want to be a mathematician or an engineer, and you need to know how to do this. Although almost nobody ever does this by hand anymore. Again, somebody's got to program the computer on how to do this. All right? That's also a good little brain exercise. All right. So now let's move on to, let's use this one now. This guy and this guy. And this is going to be weird because they're all going to make the same color. But this guy and this guy is going to make the one that goes in this blank. Huh. They don't interact at all. That's really strange. Okay. So I'm going to take negative 2 times 6 plus 5 times 1 plus negative 1 times 5, negative 12 plus 5 minus 5. So negative 7 minus 5 is negative 12. Can I do that? Yes. All right. Just like that. And let me pull my last little guy up here. And again, I just want you to see this once, because then I won't feel like you got cheated out of an education. So if you ever do take linear algebra and the guy's like, hey, check it out, blah, 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 and you're like, oh, I've seen that before, you'll learn it again in linear algebra. But, I mean, you can go ahead and do it on the calculator, which is what I'm going to show you in a minute. But as you can see, there's actually a whole lot of ways to screw this up. You could put them in the wrong columns. You could add, ooh, that's in black. You could add, you know, 5 plus 2 and get 7. Wait, that is 7. You could add 5 plus 2 and get 6, in which case your whole answer is wrong. So, we do encourage you to go ahead and do it on the calculator, just mostly because it'll help you avoid making costly hand mistakes. So, but I just want you to know where it comes from, so it's not like, ooh, mysterious calculator gives me answer. I write it down without thinking. Negative 2 times 2 plus 5 times 0 plus negative 1 times negative 2. Negative 4 plus 0 plus 2. Negative 2. Okay? So, if I have these two answers, 2, 3, or 2 matrices, 5, negative 1, 6, 1, 5, 2, 0, negative 2, that equals that. Why we want to do this? Can I just say, I'm getting tired at this point. Just trust me, it's really, really useful for all the examples I gave you before, like crew scheduling and shortest path problems. And I mean, honestly, we multiply matrices all the time in the real world. So can you just trust me that we really, really use it? And use what remaining brain power you have just to process the enormity of what you've just accomplished. Okay. Well, let's go ahead then and show you how to do this on the calculator, so you never have to do this again by hand. All right. A, B. There's my little calculator. we're going to start putting these matrices in. And, I mean, multiplying them out takes forever, but honestly, putting them in the calculator takes forever too, so I guess you just deal with what you got. Oh, we got to get the sizes of these again. This first one's a 2 by 3. I think we determined that already. A 2 by 3. And the elements are 2, 3, 6, and -2, 5, -1. Alrighty, I'm going to go back to my matrices, and I'm going to put in B, which is a 2 by 3. Good. Wait, oops, I did that wrong. I'm going to go, forgot to put the down button. Hit the down button. There we go. And this is a 2 or a 3 by 2. Okay, so it's a 6 and a 2 and a 1 and a 0 and a 5 and a -2. Alright, so I've got my matrices in there. I'm going to go back to my home page. I'm going to clear that out because I don't need it anymore. Now I'm going to go to my matrices and I want to say, well, what is A times B? And please let that be the answer we got by hand. It is! Look, we're fantastic! And look, it did it, like, right away. Okay? So, again, I just want you to know that there is a way that we get these answers, and if you do become a mathematician or an engineer or programmer, computer science, this is going to be something that's important, maybe, for you to know how to do by hand. But for the purposes of this course, let's just go ahead and use a calculator because we got them. Alright, so A times B is that. Now, here's a question. What is B times A? You say, well, it's just that thing, right? No, it's not. This is crazy, okay? So what's B? B is a 3 by 2. A is a 2 by 3. So can we multiply these together? Yes. But what's the size of my answer? The size of my answer is actually a 3 by 3. A times B was a 2 by 2, but B times A is a 3 by 3. OMG, this is crazy. So let's go ahead and plug it into the calculator and see what we get. B times A is a 3 by 3. Who'da thunk it? Alright, come here, thunker. There we go. A times B, and there's B times A. You see it? Isn't that ridiculous? Completely crazy? So what do you see here? B times A is that matrix. So here's an important rule. Oops, I need to fold. Important rule. A times B does not equal B times A. Not in general. Like, you could just luck out and the numbers turn out that way. But in general, A times B is not equal B times A. And I remember the first time I learned this, this absolutely, totally, 100% completely blew my mind. Okay? So make sure that you understand that. You can't just say, well, I'm just going to put B times A instead of A times B because it's going to be the same thing. In matrix multiplication, it doesn't. And that's because the sizes, not even the size of the answer, could potentially be different.